Kubernetes for Humans.
Hello, everyone, and welcome to another episode of the Kubernetes for Humans podcast. Today, with me in the show, I have Adam. Adam, pleasure to have you.
Hi, thanks. Yeah, pleasure to be here.
So it's our first episode for 2025. I hope we
Woohoo.
will have a nice episode today.
I hope
So
so too.
Adam,
No
without
pressure.
further ado, go and introduce yourself. Who are you? What do you do? And why do you care about Kubernetes, if at all?
Yeah, well, I'm Adam Jacob. I'm the CEO of System Initiative. In a previous life, I was the CTO and I was the original author of a thing called Chef, which did configuration management. And I'm a CEO now. I was a CEO. I was a CTO for a long time. In reality, I still feel like what I am is like a really, really good systems administrator, who's just sort of continued on that trend. And yeah, why do I care about Kubernetes? I mean, I care about Kubernetes because I care about infrastructure and have always cared about infrastructure because that's the thing I think is the most fun, and have thought was the most fun sort of my whole career. And so, you sort of can't, at this point, you can't sort of also care about infrastructure and not care about Kubernetes. Yeah.
So, it's I have to, I have to ask about the beginning and Chef, maybe if you can give a bit of details. And I'll be honest here, I can say as someone who worked with Chef, I admired Chef. Like it was a tool to do a task, but it was never fun for me at least. So maybe you can share a bit about the history of Chef, what, why, how. And I know that a lot of our listeners are using to Chef, but they are using Chef. So I'll be happy to hear about the beginning and the current state of Chef.
Yeah. So wait, you did admire Chef or you did not
No,
admire?
didn't. I didn't. I did not. Sorry, I did not admire them. I'll be honest. It was in the time when most of what I did was like Jenkins and Chef, which is
Mhm.
not the best combination. I feel for like a
It was a different
healthy
era
mind.
for sure.
No, no, for like yeah, like 10 years ago, something like that.
Yeah.
And Chef, maybe it's because the Ruby part, and I'm like a Python guy. Something never clicked. Something never
Yeah.
clicked.
Fair
Yeah.
enough. I
No,
mean,
again, like I did use it, and it was much better than what we had prior to that, which was a bunch
sure.
of bash files, right? Like it's not that
Yeah.
again, like I don't come to
Yeah.
this,
Yeah.
but
I get it.
yeah. So let's talk about the beginning of Chef, and
Yeah.
you were here for a lot
I
of
mean,
time. So
I mean uh, to think about sort of the beginning of Chef and sort of how it evolved, I think you you sort of have to put it in its context in time. So like, when we think about how sort of automation has evolved, and in particular infrastructure automation, like my career started as the internet started in the United States. And so, you know, as we figured out both how to just get everybody on the internet, and then we figured out how to like serve people content on the internet, like once everybody was on the internet, they needed stuff to do. And so we started like starting companies where what we were doing was like giving people stuff to do on the internet. And all of that didn't make sense in terms of how people understood how to build businesses, how to think about, IT. Like when you thought about like how do I run servers, what that meant was like how do I run the computers in a data center for my company, to run the applications my workers needed to do their job, which is very different than saying like what am I doing? How am I going to serve 100,000 users in an hour? Which just like nobody had ever done that before. Like there was no company big enough or with the demand enough to ever even see that problem. And so like we sort of had this time where everybody who was working in that industry, we were just making it up as we went along, like you nobody knew how to do it, so we had to invent how to do it. And when you think about the history of automation, on the internet anyway, and sort of it's very concomitant with the history of how the technology evolved, like how the external technology evolved. And so as we figured out how to build stuff on the internet, we also figured out how to automate it, because often the problem we were seeing were problems of scale that didn't exist in like legacy IT, legacy, like by which we mean it ran the world, right? So like it wasn't bad, it was just did what it did. So where Chef came from was this long, relatively, at the time it felt long, but it was actually pretty short, history of how do we think about running computers at large scale and keeping them stable and keeping them configured, where, a really common metric was like, how many servers could a single systems administrator manage? And, if you were doing it all by hand and you were really good at it, the ratio was like 50 to 1, 100 to 1, right? Um, 100 to 1's a lot. You had to be good at it. And the way you were good at 100 to 1 was like you started to write programs, right? And and so like as soon as you started to write programs, what we started to do was try to come up with ways that you think about how do I manage all these systems in a way that like allows me to do it. And so that's where configuration management comes from is this idea that says, hey, we need a method to think about how do we manage all of these computers in a more efficient, more capable way. And it starts with Mark Burgess and CF Engine, right? And the idea of like what I need is this like convergent system where the state of the computers is unknown, but I can declare the state I want to see them in. And then over time, they'll converge on the correct condition, whether or not they're, regardless of the state they're in. So, if the computer's turned off and you turn it on and it runs CF Engine, what's going to happen is eventually CF Engine's going to do all the work it needs to do to like make that thing do what it's supposed to do. And so, then there was a thing called Puppet. Puppet added in this idea of kind of a resource abstraction, where what you wanted to do was specify like the specific resources you wanted to manage. And then those things would get mapped to these like platform level providers that would then sort of do this convergent loop. What Chef's innovation was really the first configuration management system that used like a regular programming language, right? It used Ruby, partly because the complexity of integration was so much bigger. So especially when you became really large, if you were a global bank, the number of systems you needed to integrate with and the things you had to do was just more complex than you could express easily sort of in a more constrained DSL. And so it had a couple of other things in there about order and a few other things, but like that's pretty deep configuration management foo. But all of that kind of leads you to this idea where as the cloud happened, right? So Chef was released roughly at the same time as like EC2 was released. It was 2 days old, right? And so I was a consultant who was building automation for startups. Facebook apps, people forget about Facebook apps, but those were the first time you could like launch a business on the internet and instantly go viral in like in the way that we think of it now. And so I had a lot of customers who were faced with this problem, which was they just couldn't get enough compute fast enough. Like you literally, we were career systems administrators. I had friends who were, literally sending emails to everyone they knew being like, can I just buy spare compute? I'll come pick it up in a truck, take it out of your data center and put it in mine, because they just couldn't grow fast enough. And so as you got to this moment where suddenly compute was available on demand, you needed a way, even more importantly, to think about configuration management, right? Because you had gone from the limiting factor being the ability of a systems person to rack and stack compute or to think about building VMs. But even building VMs was sort of constrained on racking and stacking compute. And suddenly it wasn't that as your constraint. It wasn't, could I order hardware fast enough? It was, I could just order it off EC2 and it would just give me compute. And so what you need now, even more, is a complex configuration management system that understands how to make the operating system do the things it needs to do, bootstrap the applications, get everything set up and make it correct. And so that's what Chef did. And that was really sort of where it shined.
So, like super, super interesting story. And I feel it's a bit like the GPUs today. Like I see companies struggle to buy like, enough GPUs. And like, especially now with the rise of like ML AI, everyone's trying to utilize the GPUs better or to get like the
Yeah.
nearest and best GPUs. But walk me through like back in the day, like at least for me, there were always like the Chef, Puppet, and Ansible, right? Like it's like the three main players in the configuration management. Like, was it like, were you friends? Was it war? Like, go with, you know the problem, right? Then
Yeah.
you started like to build a solution. You called it Chef,
Yeah.
cookbooks,
We
and so
were,
on. But you
yeah.
company, right? So maybe
The,
go a bit on
yeah.
the
I mean, the people were friends,
Mhm.
in large degrees,
Oh, yeah.
um, because look, there's just not that many people who care as deeply as like I care about this topic. There just aren't. And if what you decide is that like every other person who loves what you love is a jerk, then like it's a very lonely life, you know? Like it's just you're going to be alone with the thing you care about, and it's way more fun to care about that thing with other people, you know? And
Mhm.
so, yeah, the people were friends, and we all influenced each other to varying degrees, right? So, like, I was a very prolific early Puppet user. Michael Dahan worked for Puppet for a little while, who wrote Ansible, right? We all sort of worship at the altar of Mark Burgess to varying degrees. I probably am the leading Mark Burgess worshiper, but like all of us, all of us descend from that tree in a way that like you can't avoid. And I think, he doesn't get enough credit. I think Kubernetes wouldn't exist without Mark Burgess, for example. And it's easy to forget people, because it's just people don't know. But like those ideas and those concepts and how they come together, like they're in the water and in the air because Mark Burgess invented them in like these incredible notebooks with like perfect handwriting. And, you, I think you, so like that legacy of it was very real. That said, like, yeah, we were building companies and we were very competitive, right? Like we all wanted to win. We all wanted to be the best in that space. And we did, we all built, very successful companies, that we're all, really proud of.
So what happened? Like, how much time were you like a chef, right? Like, you guys were acquired, right? Like, that's at least like that's what I remember. But
Yeah.
maybe I'm lying here. So go with me the history. Like you've been there, you founded a company, people are
Yeah.
starting to use you, like you are becoming. I want to say like the leading, like the winner in that space. At least that was my feeling back
Yeah,
then.
it
Uh,
depends on your point of view. I
yeah.
think, we won in the places where Chef was most, in the places where the complexity was highest,
Mhm.
we tended to win. I think,
Yeah.
I think by dollars, like by revenue, I think Puppet was the leader. Puppet had more revenue than Chef and certainly more than Ansible. So I think the stack rank was probably Puppet, Chef, Ansible in terms of like revenue. I think in terms of eventual share, like what's the what's the share of market? Like, I think in the end, Ansible won, right? By just pure market share, right? I think, yeah. So that journey for Chef, roughly 15 years of my life. So it started with this consulting company we ran, and then, I was for the last couple of years that Chef was an independent company. I was last year and a half or so. I was on the board, but I wasn't sort of involved in the daily operations, because I had sort of spent so much of my time going into these large enterprises, and helping them do what was then called digital transformation. You call it DevOps, you call it whatever, but I would basically take over teams in huge enterprises for a couple of weeks and teach them how to like work. Basically, how do you put all these tools together? How do you think about them? How do you do that kind of work? And what I learned from doing it was that, you know, the path to success, where success was measured by your ability to actually like support your applications and be able to do the work you need to do kind of on demand and efficiently and effectively, was so fraught with peril that almost no one was going to succeed. And it didn't mean that I couldn't teach them how I could, but they were always going to have to make adjustments. They were always going to have to make concessions for sort of the status quo. And the way that the tooling worked was so fragile that I couldn't actually get people to the outcome that I wanted them to get to and that they wanted to get to, no matter what I did. And that was kind of heartbreaking, honestly. And so I didn't want to play myself on TV. I didn't want to like keep showing up and teaching people how to do it, knowing that they weren't going to get there. Does that make sense? Like I just wasn't, like if we're not going to get there, then, and I'll be honest, like, I don't think we've gotten there now. Like, I think the Kubernetes folks have done a great job, but like their outcomes aren't better. Like if you look at the DORA report and you look at like what's the rate at which we can actually deploy our applications, you know, and who's being successful and who's in the middle. Like, we haven't moved the needle in 10 years more, right? If anything, we've gone backwards. So like, the reality is we've been stuck in this sort of same pattern. I just kind of saw it first and it broke my heart. And so I spent a few years, or not a few years, I spent a while thinking about what I wanted to do. And then I started another company called System Initiative, which is what I've been doing for the last 5 years, where what we've been doing is the R&D to figure out if we actually wanted to change those end outcomes for everyone, like what would a new system look like? I sort of became convinced that what was missing was that the core primitive we thought about when we thought about how we build automation, that primitive was wrong, that we'd been treating the infrastructure problem as a code problem in the same way that we think about applications, and that perspective was ultimately flawed. And we needed to rethink what it meant to imagine that we were automating infrastructure and how those systems interacted.
So maybe, like, so many questions. Maybe let's start with the beginning, and then I'll go with the time. What happened to Chef? Like what's the current status? Like, what?
I mean,
Why?
Chef is great. Chef is still used by huge companies. It's growing. It's always been growing. It continues to get bigger. It's owned by a company called Progress now.
Mhm.
Yeah, Chef's going great.
Okay,
I have
so
nothing to do with it, but that doesn't mean it's not successful.
yeah. Okay.
Yeah,
So the premise maybe of the current company, I'm not sure that I completely
System
figured.
Initiative.
Yeah.
Yeah.
So walk with me again. Like, I understand the problem,
Mm.
but are you guys like doing product consulting
Oh,
combination?
yeah. So look, what System Initiative is basically, if you look at the current way people work. So if you say, what is it we do? Like, let's talk about Terraform and talk about like infrastructure
Sure.
as code.
Mm-hmm.
And then we can move to Kubernetes. But let's just stick with infrastructure as code for a minute, right?
Oh,
Like,
sure.
you think about, I want some infrastructure, so I write some infrastructure as code. And then what do I have to do? So I have to figure out, like, how do I plug that together into a pipeline? What's the GitOps flow look like? How do I secure it? How do I relate to it? And then how do I teach other people to use these abstractions I'm building? Because what we're trying to do is sort of get to a spot where somebody can be like, I can deploy my application and the infrastructure is on top of it and I understand how it all works. And it's kind of a mess. And if you actually ask people how they feel about it, they're really pleased that it works. You know what I mean? Like, if you have it, you're stoked because it's better to have it than not to have it. And if you go, well, how did you feel about your day when you did it? They're like, oh, it's miserable. It sucks. Like, everything about it is painful, right? It's bad. The feedback loops are terrible. It's hard to compose. It's difficult to reason about. It's very difficult to share. The abstractions get weird. Like, there's just a lot in the way. All of that adds up to slowing down in the end. Like, we just wind up not being able to do the things we want to do because there's too much complexity in between us. A great example here was, I was talking to some folks who were incredibly great Terraform users, like world-class Terraform engineers. And, part of what they do is like set up platforms for other teams. So other teams spin up a project, they come ask those people what to do. And like, you know, what happens is they have this long pull request thread where people like try to build it and then fail. And then they go back and forth about all the ways that they messed it up. And, hours or days or weeks later, eventually that thing merges and then maybe it builds you some infrastructure that works. And so what System Initiative does is say, hey, the problem here is actually that infrastructure is not like an application, right? The issue here is that we started writing code and we started packaging it up like applications, but it's not an application. And instead, what we need is a primitive that allows us to work with this system more like, for example, the way game developers work in Unity, right? Like, infrastructure is a thing that we can model. It's a thing that we can understand. And so what we do is we build digital twins of digital things. So we build these really high fidelity models of your infrastructure. So like EC2 or VPCs or whatever it is you want to model. We model it 1-to-1. And then we allow you to then use that model in different ways. So you can program the model, right? So you can extend how it works. You can also then compose the model visually. So you can basically put, what looks like a living architecture diagram together on this canvas. And what it's actually doing is composing together all of the different pieces that you want to use in a simulation. And that simulation can then tell you, hey, this looks like it'll work. It looks like it won't. It can, automatically update values for you. And behind the scenes, it's this big hypergraph of all of these functions. So the net effect is that, like, rather than thinking about your automation solely as a piece of code pipelining, instead what you do is work in what feels like an IDE that puts together a model of how infrastructure works. And then you program the model. And then the model keeps track of what you're doing and then knows how to apply that to the real world. And it keeps track of both kinds of state, right? It knows, like, hey, this real world thing that you're modeling looks like this right now. Your model looks like this. It's all multiplayer. So when we collaborate together, you see updates happen in real time, right? As you merge things, they show up in other people's change sets automatically. Like, system initiative is super cool. And it's really the first new automation primitive, like, conceptually, right? Where the tree it comes from is not the same that's been built in the last, like, 20 years.
Now that sounds very ambitious, like super ambitious. How are like big
It's crazy
organizations?
ambitious.
Yeah. How are organizations like reacting to that? Like, are you like?
Yeah. People are reacting pretty good to it,
Mhm.
but it's honestly better than I thought that they would in some ways.
Yeah, yeah.
Like, yeah. So, I mean, look, I'm very right about the problem. I spent my whole career sort of in
I'm
this
sure
space.
you are. The problem is like 100%.
It just is what it is.
Yeah.
And, when you think about solutions, it's just very, very hard, to think about what would a solution be that would be better than the status quo, especially when you know that in the end you have to automate the most complicated organizations in the world. And
Okay.
so, what we're seeing is that people who have really deep expertise in the status quo, they tend to resonate very strongly with system initiative. And so, the only real difficulty in system initiative is that the amount of stuff that we need to do in order to get people comfortable with the coverage. So essentially to replace their existing tooling is just a big lift, because you got to think about sort of, how do I map all the concepts? And so, where we're at now is relatively early, where there's a bunch of, really smart people who are really enthusiastic about what we're doing. And we're figuring out sort of how to map all of those concepts into this new paradigm. And then, every day it gets closer and closer to a thing that everybody just shows up and uses. Um, and it's the flywheel spinning.
No, again, like super, super, like, ambitious and interesting. You talked about HashiCorp, which also did like a revolution, right? In how people are defining software in a way. Even HashiCorp in its core did try to stick very closely to actual objects, right? Like EC2, load balancer. It's not that they actually created object, at least not I feel like the beginning, but more around the how can I take existing
Kind of.
infrastructure and model them, right?
Yeah.
But how do you see system like Crossplane, which I see is gaining more popularity? Is it
Yeah.
more similar to you
I think
guys?
yeah. I mean, one of the core mistakes that we've made is that we started abstracting these systems away. So, we got to talk about abstractions for a minute, because this is a little
Mm,
bit of heresy. But, like, when we talk about abstractions in software, what we mean usually is
mm.
that there's some complex interface under the hood of which my end user needs a fraction of its capability. And so I build a new interface that allows them to, like, operate only at the high level for only the thing that they need. We call abstractions leaky when what the complexity is of the thing under the hood, it becomes the surface area of the thing at the top, right? And at that point, the abstraction starts to break down, because it's not really an abstraction. It's really just a restatement of what it is that's under the under hood. So you can see this a lot if you look at, like, a Helm chart that's goal is to fully automate every capability of the thing that it deploys. The Helm chart then grows to be roughly the complexity of the thing that it's automating. Only you have to understand both Helm and the thing you're automating and the way that the person who put the chart together put it together. I call this the 200% problem. Chef had this problem. Puppet had this problem. Helm has this problem. Terraform has this problem. Everybody has this problem, right? It's inherent in the way the system works. And part of the reason that this happens this way is that when we're thinking about infrastructure, we're not thinking of it as a one-to-one model with its actual capabilities. We're always trying to twist it into the shape of the program's understanding of what it is. So Crossplane, for example, looks at infrastructure and moves it into the shape of a Kubernetes CRD, right? It's like, I don't know what your infrastructure does. I don't know what the capabilities are. I don't know anything about any of that. What I'm going to do is turn it into a CRD so that you don't have to think about it. Well, except when you do have to think about it, except when that CRD doesn't quite do everything you need it to do, except when it doesn't come together exactly the way you need it to do. And then what happens is the abstractions we try to build on top of that, where we're like, well, don't worry about it. Crossplane, nobody should ever have to touch Crossplane, right? Shouldn't have to actually understand how that works. Instead, you should use this higher level platform abstraction, and then you never have to think about it. And the truth is, can I swear? Is swearing okay? Just a little bit?
Yeah,
Uh,
I'm good, very good.
it's bullshit. It's bullshit because what happens is the platform abstraction always winds up leaking all the way to the bottom. And you can see this with everyone who's ever tried to abstract Kubernetes, right? Like Kubernetes is such an incredibly strong point of view about what the interaction model is with the API surface that when you try to abstract it, you just wind up leaking Kubernetes' point of view because you can't not. Do you know what I mean? Like it's got such a strong perspective, which is why it's so successful. So like, it giveth and it taketh away, right? So like it's incredible and its point of view is so strong that you can't really build on top of it without leaking everything about how it behaves. So when you think about how infrastructure evolves and how models evolve, flipping from saying, hey, what we're going to do is try to build a program that understands how to abstract this low level infrastructure and its capabilities to a program that says, nah, we're just going to build you a model of how they actually behave. Um, and and if you think about building a model of how things actually behave, that and then what you can do is build models that rely on those behaviors and drive them compositionally. That's very different than abstraction, right? And that's the kind of thing that System Initiative is doing. And it's why what you tend to see when we glue these systems together is that they don't scale very well semantically, right? They scale okay for a developer. But if I try to say to a software developer, hey, here's how your application works, and then let them under the hood go drive deeper and be like, well, how do the AWS resources that run? I know behind the scenes there's load balancers. I know behind the scenes there's a Kubernetes cluster. How do I understand what that is? The answer is you just get punched in the face. You're like, well, go read whatever the definitions, try to figure it out. And like that level of mapping is so brutal. And so with System Initiative, that mapping kind of goes away because instead what you say is, hey, model your application as a thing and it has behavior. So for example, we have a model of System Initiative. We deploy System Initiative with ourselves. And one thing you can do with the application is dynamically change its tracing level. And so the high level abstraction of the application has an action on it, which changes the tracing level across the fleet. And that thing has relationships that go down to the low level infrastructure. You can also see that there's a load balancer. Do you know what I mean? Like it's the way it's composed is different. And that composition is critical to letting people scale organizationally because you can think about saying, hey, I only want to look at my application. But if I want to understand what the infrastructure looks like, I can dig into that, right? I can dive down into it. Nothing's hidden from me. In the same way that if I'm a game developer and we're building Grand Theft Auto, it's not like I couldn't look at the code that gets generated for a shader or write it by hand. I could, but I don't. Instead, what I use are all of this incredible tooling that allows me to see a scene that gets rendered and place a character in something and do those sorts of things. And that's what I'm talking about. And that's the problem with our tooling, because we've had this point of view all along that says, let's pretend infrastructure isn't infrastructure. Let's pretend it works like software. That's bullshit. It doesn't fucking work like software. It's different. And we need to
It's
model
like,
it like it is.
let me know. Like, first of all, it's a super interesting take on like a really painful like problem. But in end of the day, my skeptical side will say something like, what you say sounds magical. What happens once I try to change the tracing level, right, of my application? and for some reason it doesn't work as expected. Like when you force me to go down to the rabbit hole in Unity, or I think I never program like compute like games, but I think the engine is super solid. It works on all of the time, and that's great. Like as long as you can trust the engine, it's great. But it's a bit like I'll give like an example that I know a bit better, like Python and C. You almost never need to troubleshoot or debug some NumPy or whatever the actual C extension because it works well most of the time.
So you do.
The question is, are you at the on pair with that level of like like troubleshooting and debugging? Like once you stop working, then all of the magic goes away, right? Like I'm a Python developer that is now forced to know both Python and C. In your example, I need to know your point of view, but also to go down to the actual.
You don't need to, because the truth is what we've always done is collaborate with other people. And the problem is that we can't do it because we don't have a model of how things work. When you talk about the engine being super solid, that's what I mean. The engine has a conception of what a video game is. And we have a conception of what infrastructure is and how it behaves and how it relates to other pieces of infrastructure, and allow you to model those things in that way. And it turns out that that conception also extends up into things like applications and scales semantically. But that core primitive that says, no, actually, I don't know what it is that you're trying to automate. What I know is that we can model it and work on it in this simulation and track its behavior over time. And if we program it that way, suddenly it unlocks all of this collaboration. For example, when we built our own SaaS, so when you use System Initiative, you just come to the website and sign up, and you just wind up in this workspace, and it just happens for you. It's super easy.
Mhm.
And that SaaS deployment, we built it together. So like our team in the same workspace in real time, we're just collaborating on different parts of the infrastructure. Like some people were doing low level stuff they understood, other people were doing higher level pieces. Like you're not forced to stare at all of the details, right? What happens is that you collaboratively understand the pieces. The same way that like if we're building a complex video game, it's not one developer who does it alone, right? These are incredibly huge teams. You ever finished a video game and watched the credits roll? Holy crap. And like it's roughly the same level of complexity as the number of people involved in running a giant application for a global company. Yeah. And like, we got to give them a platform in which they can collaborate in that way. And they don't have one. Instead, what we give them is this idea that they should all be software developers who all understand every piece of the stack, which is why you're sort of forced to do it. And so that like the entire frame of your question where it's like, well, how can I deal with this abstraction? Like, am I forced to understand how, the C extension for NumPy works? And the answer is no, but someone does, right? Like the people who wrote it do. And what I need to be able to do is move between them only if I need to move between them. And yeah, it's going to be vanishingly rare that a random application developer sitting at a global bank who's running on top of a stable platform needs to go all the way to the bottom to understand like how did the IAM rules get set that give them permission for their application domain. They won't need to do that. They'll probably never look, but there's someone who does. Right. And like, and all of that information needs to live in the same place. Right. Because it's all actually the same piece. It's all of a piece. Does that make sense?
Yeah, it does. It does. I think it comes down to the promise that I won't need to look under the hood most of the time. Like that is where, if you are able to provide that level of engine, I think it's like most of the people never see any C code. Like most of the Python developers, I worked with like Apache Storm that was written in Clojure, and after like 3 years, I only needed to debug Clojure once, and we had some very hardcore things there. So
Sure. Because you just
as long
used
as
the
it,
program.
yeah, yeah,
Yeah.
yeah, as long as
I
it
don't think
works.
that's a particularly hard problem. Right. If what you do is think about it, think about how that works today. If you're an application developer and the infrastructure that your application runs on was deployed with Terraform or deployed with Kubernetes, and I tell you to go troubleshoot it, I just told you to go fuck yourself. You don't understand it at all. And the amount of stuff you have to climb up in order to understand it, brutal. Crazy, right? Think about cross-playing. You're like, okay, can I understand that there's a load balancer in AWS? Yes. can I understand that that load balancer got provisioned because it got translated into a CRD, which then gets translated into the high-level YAML that I did, which then went through our GitOps pipeline, which ran from this other thing, which ran from that thing, which ran from this thing, and then don't worry about it. We stuck it behind Backstage. No, no. Like a normal person, no. In the same way that you didn't want to have to troubleshoot Clojure, right? And so, like, thinking about how does the system relate? Like, what is the primitive we use to model it? That's my point. Like, we don't have one, and that's why we're suffering. Because if we had a stronger conception of the engine, if we actually had a conception of like, well, I do know what the load balancer is, and I do know how that load balancer relates to this other thing, and I can understand if I need to what the code is that causes this to happen. Suddenly, those semantics become elegant, right? Suddenly the ability to move between them becomes a question of whether you understand the domain. And then because you make the whole application multiplayer, it becomes a question of whether or not the right people can come help you understand it, right?
No, but that makes total sense. Really total sense.
But it is crazy ambitious, right?
Yeah.
It's like a
Mhm.
complete, like I said, it is the first new automation primitive, really, like foundationally different in the
I
last
agree.
long time.
I agree. So we are, to be honest, like like already out of time, but I will give you like 2 minutes to talk about prediction and anything else you would like to talk about.
Oh, what's my prediction? I guess my prediction is that, uh, I think that what we'll start to see is not only system initiative, but multiple new attempts at thinking
Mhm.
about how to approach infrastructure automation. I don't know what they'll be or what their takes will be, but I think in the oncoming years, the the shape of our current approaches and the idea that the sort of platform is going to evolve in the way that people have said that it will, like, you're starting to see the people who sort of understand infrastructure best and who understand the system the most. Um, they're not rejecting that idea, but they're pretty clear that that um that it's not working the way they need it to work. And so I think we're going to see more and more new attempts. And the ones I'm most excited about are the ones that are taking really wild swings, right? Like, I want to see more system initiatives. I want to see more wings. I want to see more, like, I don't know what Brian Grant's going to build, but I want to see what Brian Grant builds. You know what I mean? Like, people got to get a little crazy, because the status quo is not working. And the idea that what we're going to do is leverage the status quo in order to get a better outcome in some dramatic way is false. And so, like, if we're going to do better, we have to actually build. And I'm really excited for that era of building. And that's my prediction, is we're going to see more people build.
Okay, okay. Sounds, like fair enough. Fair enough. Like, to be honest, he's also building something in like the config space, right? I'm not
Mhm.
mistaken with the Alexis from like a we've work, right?
Yeah. Yeah.
Looking, and Jasper as well. Like a
Yes.
really strong team of
Very
people.
strong team. Right.
It one of them I think is like the, I don't know, like a top A player in the world pretty much. So
Yeah.
okay, okay, interesting. Maybe I'll bring Alexis to an episode as well.
You should.
Um. Anyway, any last words, Adam?
That was it. Thanks for
No,
having me. I appreciate you.
no, sure. I think it was one of the most like interesting like episodes. I'm sure that a lot of people like me that have done like infra IAC automation. It's like a very cool and weird concept that I need to think more about. And I really like the analogy of like basically games compared to infrastructure as code, because I do feel there's like some great overlapping in how you describe it and how I think most of the hardcore engineers feel around that, like infrastructure engineers.
Yeah.
So pleasure having you. Are you
Thank
going
you.
to go to KubeCon London? Will I see you?
I don't know if I'll be in London. I was in North America, so we'll
Oh,
see if I wind up in London. But
okay, cool. So pleasure.
pleasure. Thank you.